What is unreachable states? So if you cannot reach to a state from initial state, it is unreachable state. Okay, let's say this is your DFA Q0 and this is the language. L is equal to A, and alphabet is simply A. Okay, so what is going to be the language of it? Q0 is going to give A, and this is going to be a final state because A is a part of language, and another A is also goes to Q2, and Q2 is also final state because A is a part of language. And the moves for Q2, if you get another A, then it should go to a dead state, right? So this is the DFA for L. But as I have said earlier also, that for a given DFA, for a given language, you can give as many DFAs as possible. Okay, so what you can do is that, let's say this DFA has Q4 also, Q5 also, Q6 also, all of which are going to itself. On seeing A, all of which are going to staying at itself. So this DFA, after introducing these states also, the DFA, the net DFA, if this is the DFA, so you can have as many as these type of states, Q4, Q5, Q6. This DFA is still the finite representation of this language L only. Okay, so you can have as many unreachable states in your DFA. You can introduce as many unreachable states in the DFA. It will still be the DFA of this language only, right or not? Because from initial state you are reaching to the final state, which is conforming this language. Of course, because the strings accepted by this DFA, are A and AA only. All other strings are going to be either stay on Q0 or Q3, which are non. So you can have as many unreachable states, Qn plus 1. You can have many unreachable states. The DFA does not, it is still the DFA for the same language. So what is an unreachable state? The state that cannot be reached. A state that cannot be reached from initial state. A state that cannot be reached from initial state, that is a unreachable state. So it might also happen that I have Q7 and Q8 and they have moves among themselves. Q7 and Q8, they have moves among themselves, but still, can you reach Q7? Is there any way when you are scanning the string, so when you fed a string to this DFA, is there any way that Q7 can come? No, you cannot come to Q7 from Q0. There is no path from Q0 to Q7. Similarly, there is no path from Q0 to Q8. There is no way you can in the state sequence. So no way you get unreachable states. No way you get unreachable states in the state sequence, right? There is no way you get unreachable states in the state sequence of a string. So what is the purpose of these unreachable states? So just think about in mind. Okay, just go to a few videos back when we were constructing DFA, and largely so far we have just constructed DFAs for finite languages only, and we have just taken one example of a DFA with having loops inside it to get a sense of what we will see in the upcoming videos when we will be constructing infinite languages, DFAs for infinite languages. But what I am trying to convey right now is this, that unreachable states will not come in the state sequence of a string. Okay, so basically unreachable states are of no use. Okay. Okay, actually I have lost my slides of this video, so I am playing my own video to explain things. Okay, just look at the observations that I have made in the finite languages, in the DFS for finite languages, that there is absolutely going to be the case that there's going to be no loops. There's going to be no loops. There's going to be no self loops if the state is not a dead state. So does that hold after reading about the unreachable states? Means, if I ask you that is it technically possible for you, the reasoning behind when I said this thing, the reason behind this, you don't see any self loop or cycle of states. You don't see any self loop or cycle if states are non-final or final. The reason was very simple, that if there was a cycle, let me pause it. So when I said this, that you don't see any self loop or cycle if states are non-final or final. Okay, the reason behind it was simple, that if there was a cycle or if there was a self loop, then it would give rise to that this would be the DFA for this. It will be the DFA, but if it will for some other language which is going to be some infinite language. That was the reasoning. That was the observations. That was the reasoning for this observation. But technically you can have a DFA in this DFA also. Technically you can create a DFA for a finite language which loops between the states, which is not a dead state. And how? By giving as many unreachable states as possible. So I can have as many unreachable states. So let's say QU is QU1, QU2, all these are unreachable states, right? They move within themselves. But you cannot reach these states, so these are unreachable states, and you will never have unreachable states in the state sequence. So technically it is possible in your DFA to have a loop. For example, you can have loop, but technically it is possible, but it would be between the unreachable states. So the observations in the previous videos and the observations in the upcoming videos, or take this video as a disclaimer that I will not have unreachable state. I will not take unreachable state into consideration while talking things. Normally when you construct DFAs, you construct it in this manner only. Okay, only a insane person would be introducing unreachable state. So this is normally how it goes. So whatever observations, whatever findings in any section that I will be talking about, it will be based not taking into account the existence of unreachable states. And as you go along this course, you will yourself differentiate it. Okay. If you are given a DFA, and you figure it out that this DFA has unreachable states, then what you should do is to ignore those. Just ignore it, remove it, make a fresh DFA without that unreachable state. Okay, and you will see this in the upcoming video in the minimization of DFAs. Because in the minimization of DFA, that the first step is to remove all the unreachable states. Okay, thank you. I think I should end this video right now.